Hello and welcome. Now we will tell you about the creating the software for safety critical system. In the previous lesson, we show how to make the architecture. Our architecture divided on the three parts. So this is the mechanical parts, energy production, telemetry, and a mind controller, which is shown in the green. So in this lesson, we will focus on this green one. What is important from this? We will discuss. So in this lesson, we are focusing on the software requirements, developing software architecture design, software design and implementation of this. This system is focused on the safety critical system software developing. One of the most important keys of preparing the next steps is preparing reliable, good, complete, correct requirements. We are focusing on do this by using the methodology ERS. That methodology was developed by the Alistair and Rolls-Royce in 2009, and they show how to do this. To make no mistakes and no misunderstanding of the requirements, because the requirements are based for software development. The next step is preparing the software requirements, which tell us what we want our software to do. For example, that leakage sensor shall drive the emerging signal when the leakage is above the desired level. All the requirements are based on the requirements for the architecture, but it should be implemented very short. For example, the emergency switch shall be checked for the error. That gives us the base for developing our software architecture and software themselves. We divided this in 4 groups. First, the algorithm has to conditioning the data to what we have from the sensor and check it. The next is the emergency check. Then next part is the control algorithm. And the last part is output signal calculation. All the elements what we made will be made in the Ansys SCADE suite. So here we have the example of one of our functions. This is the data conditioning. When we take the data, condition it, and after that we will check it. In Ansys SCADE suite, we use the graphical design to create the functions, and then we generate the code from it. So this element can be also duplicated. This is not only the function for single input, but it can be used in different input. So we make a library for our function. The next element is the emergency check. All this the emergency signal what we get. For example, the leakage sensor level. Here for example, the pressure and input. There are also the emergency switch, the emergency button. Everything is gathered to have the information that we have the emergency stop or not. And the last and most important element is of course, the control algorithm. And this is our state machine which take care of the system. And this is the heart of our system, so state machine. This goes through 4 state status, which only one is the main state for driving the car. That is the working part when we calculated the real value, the value of the output system. It is included every algorithm that we need to drive the cars, but the rest of these systems are developing for the safety features. So this is the checking the information, staying in the systems in idle when there is a start of the system. There is also the reset. When our algorithm is working is depending of the emergency signal that we calculated earlier. And the last element, what we have in here, this is output signal calculation, which gives the information from that algorithm and sending to the element, like valve, engine controller, fuel cell controller, etc. And here is example of the code generated using the Ansys SCADE suite. From the functions, which we showed you before, which are the graphical ones, you can generate the code, and it is created in the safe way. So what is important, the Ansys SCADE give us a possibility to create the code, which is the reliable, safe, and safety critical. In the very easy way, we just draw the algorithm, and then we automatically create the code that is written in C and can be placed on our controller. The next important things that we can make are traceability. Traceability gives us information that these elements of the code are connected to the requirements that we set. So, all the requirements must have elements traced in that code, and also all the elements of the code have to be traced to the requirements. That allows us to be sure that every system is made correctly and working on the system is safety critical. Next, here is the way you need to go when you want to create such a system. You can do all of this using the Ansys SCADE suite or the Ansys SCADE programs. First, as we said, you need to start from the requirements. Then you need to create the good architecture, the user case telegrams, then connect the traceability, and at the end you can automatically generate the code and test it. What give us that methodology? That methodology give us an assurance that we fulfill the standard of the programming. So, we know that the program what is developed, the code what is developed, is made correctly and is safety critical. That also gives us a possibility to work with the multidisciplinary group. The methodology based on model-based design, as you see, Drawing the algorithm is much easier to understand not only by the software engineers, IT engineers, but also the electronics, mechanics, mechatronics, or any engineer that are involved in this project. Also, preparing the good requirements and making the traceability in the system allows us to generate a very good rapport. That is easier for us to show for the judges or during the testing the system in the competition, but also give us the possibility to pass it to new generation of the students. The students that will come in the next or few years later, it will become easy to understand what is going on in the system for them. So Ansys SCADE can help us in this subject. Thank you very much.